All right. Welcome to this week's lesson. My name is Professor Andrew Chepkowski, and we're going to talk about code formatting and some tools to help you get it done. We're going to focus on this concept of clean code throughout the rest of this course, and it'll be implied that your code will be well formatted from this point on. So, clean code has no strict definition, but really, clean code is going to allow us to create code that's easy to read, maintain, and understand. And as you expand on your code or change it, these clean code standards will help you uh, reduce the amount of errors that you might incur. So why would we want to go ahead and use clean code? Well, there's four reasons, and you can probably think of a bunch of more, but the idea is maintainability, reducing technical debt, working efficiently in an agile development environment, and it helps build successful projects. With agile development, often you're working in a group environment and you want to be able to deliver features and bug fixes on a predictable pace. When I'm developing on the ArcGIS API for Python and the team that I run with, we have a predictable cycle that we have to get things done, and we follow the agile development pattern to get that done. So one of the things that makes this possible is our code must be maintainable and not written as one-offs. So we focus a lot on standards because oftentimes we have to go back 3, 6, or even a year from now, and we have to remember what we did. But if we just did whatever just to get it done, maybe we went to Stack Overflow or asked ChatGPT how to do it without understanding why we did it, we wouldn't be able to go back and understand the code that we did and why we did it for what reasons. We want to reduce technical debt whenever you're working, whether it's a small project or a large project. Technical debt is basically a problem that arises from compromise or bad decisions being made. You can think of the problem like this. What is the problem that we face today and how are we going to fix it? Maybe we need to get something out the door tomorrow, or somebody says we have to. So, do we just make it work today and worry about it tomorrow? But we don't know what's going to happen. So, let's say you have a client that you're making a widget for, and that widget comes back to you a year later and they say, okay, now I want to add feature D. And feature D might be really difficult to do because we just sort of hacked it together and got it out the door. So if you stop and take time and have fixed it the right way or done it the right way, the standard way, you won't face that problem in the future problem. So in general, the shortcuts that we do today could break our code tomorrow. And this makes our code tomorrow very hard to update. This is sort of a silent problem that creeps up over time and as your project grows. And it often involves heavy refactoring or heavy redoing the code. So we want to avoid that at all costs. With code formatting, these are tools that follow standards like PEP 8. And clean code isn't just about this standard, it's about but it helps with reading your code that you have there. We want to keep code formatted and it'll help you with searchability, consistency, better error handling, and code quality. With searchability, it's going to allow us to identify tokens in our code at a glance. That means we can find something easily. You hit Control F or whatever it is on your IDE, and we can find it. Then we're concerned about consistency, which will give us a uniform format that's easier to read. And then we have error handling. If we follow the clean code practices, we can limit the number of try and accept cases in there so we don't have them strewn all over the place and errors fail silently or don't service at all. And then code formatting really helps us with the code quality. By looking at your code structure and fashion, you'll become more proficient and understand it at a glance. And that's helpful from not only looking at your code, but somebody else's who follows the same exact practice so you can work on a team. Next, that leads to docstrings. Docstrings are information about a function, class, or module, and it tells you what's going on. So basically, it tells you the story of this function. It might tell you how to use it, and it can even tell you things like return types and other pieces of information. When you go into an API or a team and you're new, doc strings are going to be your lifeblood here. You want to find the doc strings, figure out what's going on, and then you're able to get your work done that you want to do. So your code should have doc strings embedded in the source code. Doc strings are usually literal strings placed within a specific location in the code. The documentation provides the instructions, like I said before, for how the code functions. Here's an example of docstring. Here we have a simple function uh, called addition, and it has the three literals with a description of how this function works. Now, we don't have any information about what A and B are yet, or understand why they weren't added. So let's go ahead and take this concept of how somebody knows what to pass into A or B. And this is the idea of annotations. This is a recently newer PEP that's been introduced, a Python standard, in 3107. And these are hints that we put on the inputs and outputs of our functions to tell them what we're getting back. So these hints um, can go on all methods and functions, and they can also be labeled on individual variables within your code. But they're just that. They're just hints. They won't do type enforcement. You'll still have to check if something is the variable that you expect in vanilla Python. If you were using MyPy or a different one that actually enforces annotation, that's a completely different story. So continue on with the docstring example. Now we have our variables A and B. Here we have something that says A, colon, and then it says int, and then a vertical line, and float. That vertical line is an OR symbol. If you're familiar with pandas, it'll be really comfortable for you to say, or think of it that way. So we're saying A can be an integer or a float, comma, B can be an integer or a float, and then we have our arrow pointing out, and it says it can return either an integer or a float. And that's because when you pass in a variable of two integers, it'll return an integer. If you return a variable that's an integer or a float or a float or a float, it'll always return a float based on the types. So those are type hints. So in this course, we'll expect you to use the Black Python package, and I recommend using Visual Studio's Code with their extensions in order to do this. And Black is an uncompromising Python code formatter that really helps you enforce that PyStyle format that doesn't require you to do it manually. It can be installed through pip or conda. Below is the pip way of installing it. So you just do python-m pip install black. And for this course, I'll be using 24.8.0. Pylint is strongly recommended as well for this course, though not required. Pylint will basically be a quick check on if you're missing anything in your code to find errors. It checks for missing docstring, unneeded variables and assignments, and much more. Since after this lesson, you'll be required to include both docstring and annotations, Pylint is a good way of ensuring that all the code that you turn in for this course has those components to it. For those who are uncomfortable or unfamiliar with Visual Studio's code, you can go ahead and watch this video, which will be attached in the slides and also within our module for the week, about setting up Black in Visual Studio's code, as well as another slide and link that shows you how to set up Pylint within Visual Studio's code. As always, if you have any questions, feel free to reach out to me directly through Canvas or through email. And if you have any questions, also post them in the forum. Thank you.